Alrighty, good morning, everybody, and welcome to the wolfSSL live webinar, wolfEngine, or wolfCrypt as an engine for OpenSSL. My name is Kajal, and I will be hosting this, or I will be moderating this webinar. As always, all attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand to be unmuted if you would like to ask the question live, as we do host a Q&A session following the presentation. This webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I also invite everyone to follow us on Twitter at wolfSSL, as well as all of our other socials, also at wolfSSL. And please feel free to email us at facts@wolfSSL.com if you have any additional questions. And now I'd like to give a brief company overview before we move on to the technical presentation. So wolfSSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized there wasn't a open source dual licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 40 dedicated employees in 2021, most of which are engineers. This progress is, of course, supported by a strong partner network that we're very proud of, which includes ISRG, STMicro, and Curl, for example. Since the beginning, our team has developed several embedded security products, including wolfCrypt with DO178 support, FIPS certification, and a FIPS-ready offering, MQTT up to the version 5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, a embedded IDPS known as wolfSentry, as well as Java wrappers and JSSE support, and commercial support for curl. All of these offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'm going to hand it over to Hayden for the presentation.
Thanks, Kajal. So I'll begin sharing my screen here at the presentation shortly. And all that information that she just covered will be available in the slides for this presentation at the beginning if you want to receive that afterwards. But yeah, I'm a software engineer here at wolfSSL. I'm one of the primary developers of wolfEngine. So I'm going to talk about it at an architectural level and then get into the weeds a little bit with how it actually works. So just give me a moment here to set up my screen. Kajal, can you confirm that this looks okay?
Yeah, everything looks great.
Great. Okay. So wolfCrypt is wolfSSL's internal cryptography library. It's designed to be lightweight, used in embedded use cases, as Kajal touched on. And importantly, it's been FIPS validated as part of the FIPS module, which is going to be instrumental for the wolfEngine use case. So the OpenSSL engine API is a interface that OpenSSL is designed to allow things like hardware accelerators or other cryptography libraries like wolfSSL to be plugged in and used for cryptographic functions and algorithms. And so what we've done is we've taken wolfCrypt FIPS, which again is FIPS validated cryptography library, and we've plugged it in via that engine interface, and we've called it wolfEngine. And you can now use OpenSSL as is outside of the cryptography bits that are going to be delegated to wolfCrypt instead of using our compatibility layer. And so this is an alternate approach to getting FIPS compatibility via wolfSSL if you're coming from OpenSSL. And I'll go into that in greater detail as we progress through the presentation. So at an architectural level, this diagram on the right sort of depicts how wolfEngine fits into the OpenSSL framework. And it's basically what I just described. The engine framework allows you to register different methods for different algorithms. So we've got, for example, methods for ECDH, RSA, AES, triple DES, things like that. And then whenever OpenSSL needs to use one of those functions, it looks at its list of engines. And if wolfEngine's been registered as the default, it's going to use that instead of the internal OpenSSL implementation. So I want to talk a little bit about the different ways that wolfEngine can be initialized and used. So engines can be used in three primary ways that we've identified. So you can load the engine dynamically. And basically what that looks like is in your application code, which I'll show shortly an example of, you register wolfEngine as a dynamic engine. And basically what that means is you just tell OpenSSL where to look for engine shared objects. It's just a shared library on Linux. It would be a .so, although we also have a static solution, which I'll talk about shortly. And then OpenSSL will be able to find that path on the file system and load wolfEngine dynamically. And if you don't want to recompile your code, if you don't want to have to add that function call in, you can also do this via the OpenSSL configuration file. So OpenSSL comes with a configuration file where you can change things at runtime by just modifying the config file instead of having to recompile anything. And so that's a good option if recompilation is expensive or you just want to give it a try. If you want to give wolfEngine a try, that is. And again, wolfSSL is always focused on the embedded space. Static builds are extremely common in that space, and so there's also a way to modify your code to load wolfEngine statically alongside OpenSSL and wolfSSL. The versions that we've done the most testing with are OpenSSL 1.0.2, specifically 1.0.2h and 1.1.1b. It should be noted that OpenSSL starting in version 3.0.0, which is the latest and greatest, sort of forever coming out version of OpenSSL. They've gotten rid of the engine API and they're using something similar called providers. And I haven't looked too much into what that API looks like, but if it's something that any of you are interested in, please let us know. Okay, so I've mentioned this compatibility layer a couple times, and for those of you who aren't using wolfSSL with OpenSSL's compatibility layer or aren't using wolfSSL at all, basically what that is it's a way via header files and implementing the same API as OpenSSL that wolfSSL can be. You can migrate a project to OpenSSL from wolfSSL just by strategically including headers and defining a few macros, and then all the OpenSSL function calls in that project will just be replaced with wolfSSL calls. So in the end, OpenSSL isn't there still, like in the wolfEngine case. It's been completely replaced. The application won't link against OpenSSL. It'll just link against libwolfSSL. The interface is the same. So you can still call all the same functions, but if you were to look in the debugger under the hood, you just see that it's calling wolfCrypt. It's not actually calling anything in OpenSSL. So that's the compatibility layer. So I like to think about the compatibility. You know, wolfSSL is this fast car over here on the right, and OpenSSL is this PT Cruiser here on the left. Not to insult any PT Cruiser owners, but getting wolfEngine is like taking the engine from the car on the right and putting it in the PT Cruiser. So if you need quick FIPS, if you need something just to get you to FIPS compliance in a timely manner, wolfEngine is probably going to be the better solution for you. If you want to get rid of OpenSSL entirely, be off of it, and do a clean migration to wolfSSL, or you have size constraints, like you're an embedded user, you're probably going to be more interested in the compatibility layer. OpenSSL is simply too big for certain devices. So in that case, wolfEngine is probably not your best bet. So just to talk about a little bit of the testing that we've done, we've implemented tests with OpenSSL. So OpenSSL obviously has its own test suite, unit tests, integration tests, things like that ship with the source code. And we've modified all those tests to use wolfEngine so that we can ensure that the OpenSSL plus wolfEngine implementation passes all the same tests that the OpenSSL plus OpenSSL native crypto passes. And we've also done third-party integrations with, and these have not been upstreamed or anything, but we've done ports for Nginx, curl, stunnel, OpenSSH, and several other applications. So we've got tests running with those and ensuring that they work transparently as they would with vanilla OpenSSL, with OpenSSL combined with wolfEngine. All right, so as a case study, I wanted to talk about RSA key generation. And that's going to use, way back here, I talked about 3 different initialization modes. And so this example is going to rely on dynamic engine loading. And this, again, will require you to add lines of code to your application. So it requires a recompilation. It's not the same as the config file approach. On the left here, I've got a tree diagram showing sort of the source files and header files that are included with wolfEngine. Just to give you a sense of how things are structured, we basically have isolated algorithms or categories of algorithms to their own source file. It's pretty straightforward. There are very few public headers because there's actually very few functions on wolfEngine that an application can call. That's usually just handled by OpenSSL. So it's a pretty simple interface. All right, so if you wanted to generate an RSA key using OpenSSL plus wolfEngine, you'd first start by calling engine load dynamic, which under the hood gives you this functionality to load libwolfSSL as a shared object at runtime. And then to do that, you call engine by ID with the name of the engine. And then you can set, here we're setting it as the default method for everything, which means all the functionality that wolfEngine provides, so ECDH, ECDSA, RSA, AES, everything, use that whenever possible. But you can also just say, I just want to replace the RSA with wolfSSL, say. And you could do engine set default RSA and set wolfEngine to just handle that function. But here we're setting it to handle everything, which is probably going to be the most common use case. So what that does under the hood in wolfEngine is OpenSSL will find the shared object, and then it's going to look for a bind function, which is registered via a macro. And that function that we've provided is wolfEngine bind. And in there, that's where you actually would see wolfEngine supplying all the methods that do the different algorithmic functionality. And so then in your user code, you've got some existing OpenSSL function calls, like RSA generate key X, which is what I'm showing here, to generate a 1K RSA key. And what that's going to do is OpenSSL will take the call and eventually it will delegate it to the engine that handles RSA, which in this case is wolfSSL. And under the hood, that's going to call wolfEngine RSA keygen. And if you were to compile with debugging and actually run this little example, you would see that wolfEngine is being used for this operation, not OpenSSL native crypto, which again is the whole point. So that's just a little quick example, but this applies for generating signatures. This applies for OpenSSL's TLS and SSL stack. So internally, when it needs to do something cryptographic in the process of doing the handshake or bulk encryption or what have you, it's going to be using wolfEngine for that, which I'll show here shortly. Yeah, that's exactly what I'm going to show next. So let me share my other screen. Okay. How's the text there, Kajal? Is this readable? I'll just trust that it is.
Yep. I think everything looks good.
Okay, cool. Yeah, sometimes this looks small on different screens, so good to hear. This is an extremely long command line, but I'll just walk through each portion of it. I've got OpenSSL installed in a non-standard location, so I'm telling the loader where to find it. This is an OpenSSL environment variable that you can use to add additional directories to search for engines. There's also, when you install OpenSSL, it will have a default directory for engines. On Linux, that's under like, user local etc or something like that. Here, I'm just specifying it directly. And in this directory, if I were to look at the contents, you'll see that's actually where the shared object resides for wolfEngine. Next, we just have, again, I don't, this isn't on my path, so I'm specifying the path to OpenSSL. But many of you may be familiar with sserver, which is a OpenSSL subcommand that basically acts as a simple TLS server. And then I'm just giving it some parameters for a certificate and a key. And most importantly, I'm specifying that I want to use libwolfEngine as my engine. So I just ran that, and now the server is ready to accept connections. And I compiled wolfEngine with debugging at compile time. It's also something you can turn on at runtime, but this is just hard-coded in. And as you can see, it's done some initialization. It's telling OpenSSL what ciphers it offers, what digests it offers, initializing different things. So it's clearly using wolfEngine. Over here, I've got a similar command. This is just with the client-side application that OpenSSL provides, and it's also going to be using wolfEngine. And as you can see, well, maybe you can't. There's a lot of output. But basically, they did the handshake. They were able to talk to each other. Digests were computed. You can see AES GCM being used. And now we have a TLS connection. It's secured by wolfEngine, wolfCrypt FIPS under that, and ultimately it's just using OpenSSL. So that's the idea. That's all I've got. So I'd be happy to take some questions now.
And as always, feel free to use the Q&A box, or if you'd like, you might also raise your hand and you can just ask the question directly.
So I see one in chat here that came up first. I think I can take. Any thoughts on recommendations about using the OpenSSL engine API versus the lack of engine API in OpenSSL 3? I'd say as far as wolfEngine is concerned, you're kind of stuck using the engine API because we haven't ported to OpenSSL 3 yet. If you're just talking about the two, generally speaking, it's a pretty big migration to OpenSSL 3. It's a new major version of their API, so the engine portion wouldn't be my greatest concern if you're migrating from a one version, an OpenSSL 1 dot something. Yeah, those are my thoughts there.
Awesome. We have a question here that states, does wolfEngine have DO178C artifacts? And if so, to what level?
I know that we've done DO178 work for wolfCrypt FIPS, and I'm just not apprised of the details that would be needed to know if you can plug it into wolfEngine. But we have done work with DO178C. And that's something we can follow up with the relevant engineer after this.
Awesome. Is wolfEngine also supported for low-end memory devices like MCU with no crypto engine?
The question would be, can you fit OpenSSL on that device already? And if you can, if that's comfortable for your application, then plugging in wolfEngine is on the same order. So I think that would be fine. But if you're not using OpenSSL and you don't have room for it, then you're going to want to go with the compatibility layer because it's going to be much smaller. Because again, wolfEngine just plugs into OpenSSL, but it's still going to come with all the bloat of that library.
Awesome. Is wolfEngine still device or platform compliance dependent for FIPS?
For FIPS, if you mean that to be FIPS certified, you need to have your operating environment certified, then that is still the case. You can still use wolfEngine with something called wolfSSL FIPS Ready, which is our wolfCrypt library doing all the right best practices by the letter according to FIPS, but it's not actually tied to like an operating environment, which is, combination of operating system, hardware, things like that NIST requires.
Awesome. Can you talk about other usage
Yeah.
beyond, I guess, the dynamic methods that you talked about in the presentation?
Yeah, let me share my screen to answer this one real quick. Share screen. So this is a very basic OpenSSL configuration file. And this is another way you could do it. And again, this wouldn't require recompilation, which is attractive for some people. But you basically tell OpenSSL the engine ID, and you tell it where to find the engine shared object, and then you can tell it whether to initialize it at, lazily initialize it or initialize it at startup. You can send control commands to it, which is what this is. You can see the note here about debugging. So yeah, that's one way to do it. Let's see, do I have the static example? Let's see. If this takes me longer than a minute, I probably won't show it. But yeah, so this is our unit test, which can be run with the static engine. And the static entry point is called engine load wolfEngine. So this is the third option. And yeah, I think we've got a couple customers using this for embedded solutions. So that's an option as well. It's honestly been a while since I've looked at this code, so I'm not super familiar with the static stuff at this point. I guess I can take this question on Red Hat. And I think this one came through on email too. Stop my share. I think, and I got an answer on this from our FIPS expert, Caleb. So let me see what he had to say about
is,
yeah, go ahead.
Does Red Hat 7 and 8 have an OpenSSL FIPS 142 approved algorithm, and they want to know what the difference between the wolfSSL and Red Hat is?
Yeah, so Red Hat has gone through their own certification. They don't depend on the old OpenSSL cert, although they are using OpenSSL in their solution. According to Caleb and the NIST, not CIS, NIST website. The sunset date on that cert is 2026, and they have no 140-3 cert in progress. So that one that I just mentioned is a 140-2 cert. So that's one difference. And then outside of that, I'm not too familiar with their module. It's just another FIPS solution. I don't know if it's commercially licensed or it's open source.
All right. Does wolfEngine leverage the use of the crypto engine not available on MCUs? Or how is it made available for no hardware-based crypto engine?
So the default in wolfCrypt, which is the underlying crypto library for wolfEngine, is to do all of this, all the crypto in software. So there defines and enable options and different things that you can add to your wolfSSL build to compile in support for different crypto accelerators. But if they're not there, they won't be used. They can't be used, obviously. So you'll just wolfEngine will just be doing all the crypto in software, and the software can be accelerated using assembly optimized routines and things like that, and it's really fast on a lot of chips.
Awesome. How much of the stack overhead will increase, I guess, if we use wolfEngine in place of the vendor-specific engine?
I would have to know what the vendor-specific engine is to do a comparison. wolfCrypt would be, wolfEngine is basically a small layer between OpenSSL and wolfCrypt, so it itself wouldn't add that much stack usage. And we try to keep the stack pretty tight in wolfCrypt, and there are options to optimize for stack usage. So we're pretty good about that. But again, I would have to know about the other engine and what it's sitting at to compare the two.
In what aspect does FIPS provide better security than a library that's not FIPS compliant?
So FIPS compliant crypto libraries are subjected to, a barrage of tests and have to meet certain requirements and best practices and standards and things like that. Whereas you're just not getting that guarantee with something that's not FIPS validated. But more often than not, what I've seen with customers is that it's not necessarily, does FIPS provide better security than a non-FIPS library? It's a requirement that their customers have because they're doing something with the government or something like that. But the spirit of it is that you're following best practices. These are, what NIST has decided are secure algorithms, and you're subjected to that barrage of testing. So that's the spirit of it.
Awesome. And that was the last of our questions, I think. So I'd like to thank everyone for attending this webinar. We have a couple more questions now. Okay. If we have wolfEngine enabled, then in that case, other third-party library, for instance, Nginx, curl compiled with OpenSSL doesn't need to be ported to use libwolfSSL?
That is correct. So if it uses OpenSSL currently, and that version of OpenSSL supports the engine API, then we can just hook wolfEngine in, and it'll be loaded dynamically when those projects call OpenSSL functions to do cryptography. So Nginx and curl in particular, yeah, those are confirmed supported. And we also support those in the compatibility layer. So if you wanted to move totally off of OpenSSL, that would be an option for those as well. And curl actually has native wolfSSL support, because I don't know if you all knew this, but the founder and maintainer of curl, Daniel Stenberg, is actually a wolfSSL employee.
And then just adding a wrapper of wolfSSL over OpenSSL, does it really help in cyberspace?
I think it does. I think wolfCrypt is a superior cryptography library. It's, faster than OpenSSL in a lot of configurations. It's smaller. But I see the real customer of wolfEngine as being somebody who is looking for FIPS compliance. It might be faster, in certain applications from what we're seeing. It's just comparable speed. I haven't gone through the benchmarks recently, but because you're hooking it into OpenSSL, it's not going to be as fast as if you were just using the compatibility layer and you didn't have that extra translation step.
Okay, fantastic. Now, that was the last of our questions. I'd like to thank everyone for attending this webinar. As I stated before, this webinar will also be recorded and made available via our YouTube channel shortly after the presentation. If you'd like a copy of the slides of this presentation, please email us at FACTS, that's FACTS, at wolfSSL.com, and we'd be happy to send that over to you. I also invite everyone to follow us on our socials at wolfSSL, and please feel free to email us at facts@wolfSSL.com if you have any additional comments or questions regarding wolfEngine or any of our other Wolf products. And thank you, Hayden, for a fantastic presentation. I hope everyone has a great day.
Yeah, thanks everyone. Thanks, Kajal.